Okay, so in this section, we're going to talk about applications, and the reality is we have already seen one of these applications of exponential functions. We have seen our PERT model. So the PERT model is an exponential model, as we discussed in the very first section of this unit. What they're going to do in this section is they're going to formalize it to be a more general exponential model. So the way that they do that is they represent it as f of x is equal to c e to the kx. And the thing to remember here is that if you just want to go through your life thinking about PERT as the exponential model, you can totally do that. The other way, of course, is to think about it in this more generalized format of c times e raised to the kx. But the relationship is going to hold true here. The c is going to play the role of p. So p represented the initial amount. So c is going to represent the initial amount. The r was our interest rate. Here you'll notice in this more general exponential model, we have a k. So k represents the growth rate or decay rate. And then in this more general exponential model, instead of having t, we have x, so that's our independent variable, and then our f of x is going to be the amount after x years. Now, this part here of this f of x model, that is just the general form that we have. Honestly, I used to teach it with this general form, but what I found is it just causes us more confusion. So what I am going to do is I'm going to use what we already know, build from what we already know, and use the PERT model as we're explaining these exponential models. Now, with that said, I do just want to mention one other thing that is purely for your information. Technically, exponential models are very important or very defined by what we call a differential equation, and that is given here, where you have f prime of x is equal to k times f of x. And if your function, if your quantity satisfies that relationship, that's what tells you that you have an exponential model. So sometimes you'll see, like on the My Math Lab homework that we used to use, for example, they would have this relationship of n prime is equal to this coefficient times n of x. And the only reason why they're telling us that is that would be what tells us that we do have an exponential model. Now, again, in this homework, you're not going to have to identify any of this, but that used to be part of the business calc curriculum, was discussing how this is a differential equation that would then lead us to believe that we have an exponential model. So a lot going on there in this page, but really mostly for your information, the one thing that I want you to take away is we're working with the PERT model, which you can of course generalize into a CE raised to the KX, but we'll mostly be using the PERT model. And then our three goals for using that PERT model is going to be doubling time, present value, and then of course expanding to more exponential models.